So we're almost done with conditionals. I want to show you one more kind of conditional. It's a little bit different. It's not a bit of code structure that you make. It is dealing with the fact that some things may blow up. Like if you read a number from a user and you try to convert it to a floating point number, as you may have already done in some of your homework, it can blow up. You know it's going to blow up, but you don't exactly want to kill your program. So the concept of try and accept are, hey, this is a dangerous thing. I know it might blow up. I know exactly what it might blow up, but I don't want to die, and I don't want to stop my program when it blows up. I want to continue, and that's the purpose of the accept block. So here's a little bit of code, and we've done this code before. This is code that's kind of similar to like your rate and pay homework, where you read a string using raw input, you converted it using float, but then if you typed in Fred, the thing blows up. So we're kind of simulating that right here. So here we have a variable a string called hello Bob, and then we try to turn it into an integer, and then we're going to print that out, and then we have another string called one that has the letters 1, 2, 3. We convert that to an integer, and then we print that one out. The problem is that when this runs, this is going to fail. It's going to fail with this traceback. Okay? And the problem is when the traceback happens, the program stops executing. The traceback is Python's way of asking you, hey, this would be bad. I don't know what to do. I'm stopping. So that means that the rest of your program is gone. Right? The fact that we had stuff down here doesn't matter. This line died with a traceback. It stopped. It doesn't like give you a traceback and then keep going. It gives you a traceback and that's the end. Now this might be something instead of just the string hello Bob, which is insane. Data might have come from a raw input where the user was typing and you're saying give me a number, and they type something that's not a number, and this would blow up. It's like, hey, I know it's going to blow up. The problem with this is that you don't clear the thing. Oh, now I have to start it on fire again. Okay, it's on fire. The problem is that in a sense this program is you. If you recall, we have you as the typing these commands into these scripts, feeding the central processing unit, answering the question, what next? So you should take it a little personally when your program gets a traceback, because that means you, in the form of your program, have been vaporized, and you're not present to give any more instructions. It stops. It stops dead in its tracks. You are gone. So we want to make sure we control this behavior. We know it might blow up, and we want to capture the situation where it does and execute alternate code. Okay, so here it goes. It's a bit of syntax. I mentioned that it uses the try and accept keywords. These are reserved words in Python. And then it's a little indented block. So a string equals hello Bob. Great. Try means we're about to do something dangerous. Let's take out some insurance policy on it. And that is we're going to convert this to an integer. Take a stir, convert it to an integer, put it in I stir. If that works, great. We'll just continue on and ignore this except. If it blows up, we're going to jump into the accept block. And then we'll have alternate substitute code. In this case, I'm going to set the variable to -1 as an indicator. Then I'll print it out. I'll do it again. Try this code, and away we go. So when this runs, we know exactly how it's going to run. Come back. We'll set this string. The try takes out the insurance. This blows up, so it runs down to here and runs this part, and then it'll print first -1. Then it sets the string to 1, 2, 3, not 123, but 1, 2, 3 is a string. It takes out an insurance policy. This time it works, and that puts I stir is going to be 123, so we don't run the accept code, and so out comes the second 1, 2, 3. Okay, so the try is take out insurance on this little bit of code. And if it fails, run this alternate code. If not, skip the alternate code. So it's kind of conditional. If you put multiple lines in the block between the try and the except, it runs until one dies. So if it doesn't come back, okay, it's not taking insurance out on separately on all three statements. It's like, here's a block of stuff, and if anything blows up, stop. And the things that run do run. So if this is really kind of bad code because you really don't want the print in here. It's actually a good idea in the try except to have as little in the try block as you possibly can, so you're real clear on what's going to fail. But so here we come in. It's Bob, so it's going to fail. We run this. That runs successfully. This blows up, so it quits and jumps into the except blocks and continues. The point is that this code never executes. Never executes. The other point is this code does execute. Just because this blew up, this is already executed. It might have done something other more complex than print hello. Okay, so there you go. So if we look at this kind of in a picture, we set this with the try block. It runs, and the try except kind of has this escape hatch that says if there is a explosion somehow, then it runs this alternate code, and then it comes out and finishes. Okay, and again, it doesn't go back and finish the block, and it doesn't undo the work that is done by that. So it doesn't unexecute it. If it executes and works, it just keeps on going. Then it blows up and then sort of flushes its way out. Okay? So here's an example of how you might do this in a running program, like the programs that you're about to be assigned where you're supposed to check for user input having errors. So here is a little conversion of a number, and so we're saying, enter a number, and we're putting a string into raster. It's a string, and so we don't know. And here's where we're going to convert it to an integer, and we're just not sure if it's going to work or not. So we know how int works. It either converts it or it blows up. So we know it's going to do that. We just don't know what the user's going to type. We don't know. So we have to take out insurance on it. So this runs, and then we do a try, and then we try to convert it. And if it works, it's great. And if it fails, it runs this and sets it to -1. And afterwards, we either have the number or -1. And so if the person enters 42, it says nice work. Well, let's show you where it runs. If the person says 42, it runs through here, gets the string 42, converts that to an integer, skips here, and then says nice work. And that's how it runs. If, on the other hand, they type 42 the words, this gets to be the string 42. It runs here. This blows up, so it comes and runs this part here, and then it says if ival is greater than 0, which is not true, so it runs this part and says not a number. So this is our way of compensating for user input that might have errors in it, errors that we're anticipating, right? You'd rather at least put up some kind of a message rather than just have a traceback if you're writing code for somebody else. It just kind of is not very classy. So, the classic program to do this is a time and a half for overtime pay. So you get some pay rate like $10 an hour for your first 40 hours, and then you get 15 hours for any hours above it. So you have to sort of say, oh, okay, if this ends up being some kind of a thing where, let me draw that picture a little better. Hours greater than 40, you're going to do one thing, and if hours are less than 40, you're going to do another thing. So you have two pay calculations. If the hours are greater than 40, then you're going to do an overtime calculation, which is kind of like 40 times the regular rate, and then the number of excess hours, like 5 overtime hours, times the rate times 1.5. So this is kind of the calculation that happens if the hours are greater than 40. And then if the hours are less than 40, it's just pay equals rate times hours. So you're going to do one or two calculations depending on how it works. So that's one of the programming problems for this chapter. That's a classic. It's the classic if then else. You can actually do it with an if then if you're tricky. There's a lot of ways to do this. So pick one and do it. Now, The next thing I want you to do is I want you to take that same program, do it again in another assignment or another problem in the chapter, and that is have some kind of a non-numeric input and have it blow up. So if they type, something like 9, put out an error. Or if they type something here, put it out an error. Now, don't write a loop. No loop. This is one execution of the program, and this is another execution of the program. Later we can write loops. We haven't even talked about loops. So this is running it twice. All I want you to do is exit. So take a look in the book as to how to just get out. So I don't want you to try to say, I'm going to prompt for these numbers until I get a good one. We'll do that later. I just want you to deal with the fact that you read a thing, you use the try to convert it to a float and see if it works, and if you don't, you just quit. Don't try to be tricky and repeatedly prompt. So don't repeatedly prompt. One prompt and then quit. Okay? So this is conditional execution. If then else, and then I added a little bit with the try and accept as well. And the try and accept is really a limited kind of a problem. It really is to compensate for errors that you anticipate are going to happen, and you can imagine what you want to do as a replacement for what those errors are. Okay? See you next lecture.